Okay, it says the following table shows a probability distribution for a random variable x, where ex is 1.2. So this means the expected number is 1.2. Then we've got some information here. We've got x is 0, 1, 2, 3, and then we've got the probability of x, which is p, 1/2, 3/10, and q. Part A says find q. So the way we're going to do this is we're going to use the expected number here. So the way the expected number works is the number, outcome, multiplied by the probability. So it means 0 times p plus 1 times 1/2 plus 2 times 3/10 plus 3 times q is going to equal 1.2. So 0 times p, I can ignore that. 1 times 1/2 is going to be 1/2 plus 2 times 3/10 is going to be 6/10 plus 3 times q is going to equal 1.2. So that is therefore going to give me, if I change that to tenths as well, or change that to decimals, so that's going to be 0.5 plus 0.6 plus 3q is equal to 1.2. So that means that 3q is going to be 0.1. And so q is going to be 0.1 divided by 3. Which is 0.033. We can do 1 over that. That's going to be 1 over 30. So q is going to be 0.03 recurring, which is 1 over 30. Okay, so I'm going to write that in the box here, 1 over 30. And then it says find p. So because these are probabilities, these are obviously going to have to add up to 1. So we know this is 1/2, this is 3/10, this is 1/30. We can then use that to work out p. So p is going to equal, if I change all these to 30ths, that's going to be 15/30, and then that's going to be 9/30. So that means I've got 25/30, so this one is going to be 5/30, which would be 1/6. Alright, so p is 1/6. Next it says, a bag contains white and blue marbles with at least 3 of each colour. 3 marbles are drawn from a bag without replacement. The number of blue marbles drawn is given by the random variable x. It says, write down the probability of drawing 3 marbles. So when it says here it's given by the random variable x, that's this same value x we've been talking about here. So the probability of drawing 3 marbles is the probability of getting 3 in the table here, which is q, which is 1 over 30. Alright, and then it says, explain why the probability of drawing 3 white marbles is 1/6. So, probability of drawing 3 white marbles is the same as drawing 0 blue marbles. So 3 white marbles is the same, is equal to 0 blue marbles. So we can do the same technique. We can look in the table here for 0 blue marbles is what we worked out, p, which was 1/6, which is the same here as 1/6. Alright. Then it says, a bag contains a total of 10 marbles of which W are white. Find W. So I'm going to go down here to do this. So this is B part 3. Now, it says a bag contains a total of 10 marbles of which W are white. So what we want to do here is we'll work out the probability of drawing 3 white marbles, because we know that that is 1/6. So if there's 10 marbles to start with, drawing the first white one, the probability would be W over 10. Then, probability of drawing a second white one would be W minus 1 over 9, because there's 1 less marble than there was before, and there's now only 9 marbles. So then the probability of drawing the third one would be, that looks like a plus, that's meant to be divide, multiply, W minus 2 over 8, because we've now already taken 2 marbles out, they've both got to be white, so now there's 2 less than there were before, out of only 8. And we know that that has to equal 1/6, because that's the probability of getting 3 white marbles. So I can therefore say if I multiply 10 by 9 by 8 and then divide that by 6, I'm going to get that W times W minus 1 times W minus 2 is equal to 120. Just doing 10 times 9 times 8 and then divided by 6, that gives me 120. Now, because we've got to have 3 consecutive numbers here, to get 120, it's going to need to be something like 3 times 2 times 1, or 5 times 4 times 3, or 8 times 9 times 7. So we can do a little bit of trial and error. It won't take too long to work out that it's 6 times 5 times 4. 6 times 5 times 4 is equal to 120. So W is equal to 6. Alright, that's that one. So next it says, a game is played in which 3 marbles are drawn from the bag of 10 marbles without replacement. A player wins a prize if 3 white marbles are drawn. Jill plays the game 9 times. Find the probability she wins exactly 2 prizes. So we need to work out the probability that she will get 2 prizes exactly. So in order for her to get 2 prizes, she's going to need to draw 2 white marbles. Sorry, she's going to need to draw 3 white marbles twice, and then not do that a further 7 times. So 2 times draws 3 white, and then 7 times does not. So the probability of her drawing 3 white is 1/6. Probability that she does not is going to be 5/6. 1 take away 1/6. So the probability of her doing that is going to be 1/6 times 1/6 to get the 2 times to get all the 3 white, and then she's going to need to have a further 7 times of drawing the 5 of not drawing them. So it's going to be 5/6 multiplied by 7, so the power of 7. Alright, we also need to realise that there's various different ways of doing this. So she could draw white first time, draw the 3 whites the first time, draw the 3 whites the second time, and then have 7 times of not drawing them. Or she could do that in different ways. So we're going to need to work out NCR 2, 9, 2, because there's 9 possibilities altogether and she needs to do it 2. So there's 9 draws and she needs to get 2 of them right. So we need to work out what NCR 9/2 is, which you can do on your calculator, and then multiply that by 1/6 squared times 5/6 to the power of 7. So we can do that. NCR 9/2 is 36, and then multiply, change 1/6 into a decimal, so 1 divided by 6. So that's okay, and then square that, and then multiply that by 5 divided by 6 to the power of 7, and then times that by 36. So that's going to be 0.279. Just work that out and say the whole thing is equal to 0.279. Alright, so this is basically the same thing as doing the binomial expansion, which is just on your formula sheet. Why can't I show that? Oh yeah, there we go. Binomial distribution here. Alright, so probability of x of r is n over r, and then p to the power of r, 1 minus p to the n minus r. So in this case, n is our 9, because there's 9 attempts altogether. R is the number she gets correct, which is 2, and then the probability is 1/6, and then this is the 1 minus 1/6. So it's the same thing there. I've just explained where it came from rather than just sticking the numbers directly in. Alright, so that's done that one. Next, part D. It says, Grant plays the game until he wins 2 prizes. Find the probability that he wins his second prize on his 8th attempt. Alright, so in order to win the second prize on the 8th attempt, in the first 7 attempts, he's got to win just once. Wins 1 time. And then on the 8th attempt he's got to win. So we conduct this in the same way as we did with this one. With Jill, she had to win 2 times out of 9, so we did it like this. If he's got to win 1 time out of 7, that is going to be 7 NCR 1, and then 1/6 multiplied by 5/6 6 times. So that's the probability that he wins just one time in his first 7 attempts. Okay, wins 1 time, doesn't win 6 times, 7, 1, different ways of doing it, and then you've got to multiply that by the probability that he does win on the 8th time. So that he does win on the 8th time. Is going to be 1/6. So we then multiply that answer by 1/6. So that's going to give me 7, 1, and then that's going to be 1/6 squared, and then 5/6 to the power of 6. Okay, so we've got here this one, and then just get the calculator out, so I can do 5/6 first to the power of 6, and then multiply that by 1/6 and then squared, and then 7 NCR1 is just 7, times that by 7. So that gives me 0.065. Alright, that's the end of the question.